Take a look at the apps on this home screen. When you pick up your smartphone and open any one of them, you expect the experience to feel alive, instantaneous, and constantly connected. But the underlying architecture of the internet was built on a very different premise. It relies on standard HTTP, which is a strict request and response protocol. Your device has to ask a specific question before the server can send back any data. So that live, instant feeling you get when you see a typing bubble or a new like appear is actually an illusion, constructed on top of a system that defaults to waiting. Early on, developers forced this live feeling using a brute force workaround called polling. The app simply asks the server over and over again every single second if there is any new data. Every time the app asks, it has to attach heavy blocks of text called headers. These contain cookies, authentication tokens, and browser details. You end up sending a massive package of data just to check for a tiny 2-byte typing indicator. One phone repeatedly sending heavy data blocks is manageable. Multiply that by millions of active users simultaneously, and you flood the network with redundant headers. Your phone's battery drains, and the back-end infrastructure buckles under the weight of millions of redundant questions. To achieve true real-time interaction, engineers had to stop asking for updates and build a communication pipe that simply stays open. That open pipe is called the WebSocket protocol. It establishes a persistent two-way communication channel between your device and the server. It starts with a standard HTTP connection, but instead of closing after one request, the client and server perform a handshake, upgrading into a live conduit. Heavy HTTP headers are stripped away, allowing the server to push data instantly the moment it arrives, without waiting. This continuous connection enables the high-frequency updates that make modern apps feel reactive. It delivers the online status dots, the read receipts, and the typing indicators that appear the moment they are triggered. By removing the need for a client request for every piece of data, WebSockets allow servers to push updates directly to millions of users with almost no latency. But if WebSockets are this fast and efficient, why do the largest apps in the world strictly limit their use? Maintaining a persistent connection requires dedicated server memory. Holding open millions of these permanent connections simultaneously consumes a massive amount of expensive server resources. It also creates a complex engineering challenge for load balancing. Because these network pipes are continuously open, they cannot be easily closed, paused, or rerouted when traffic spikes. Compare that to a standard HTTP request, which is stateless. It performs a specific action, verifies security, delivers the data, and immediately closes the transaction, freeing up the server. Treating every single user action as a persistent connection would cause a billion-user app to collapse under its own weight. So engineers split the workload between both protocols. We can see exactly how this hybrid architecture works by tracking a single chat message on a platform like Slack or Discord. When you type a message and hit send, your app relies exclusively on standard HTTP. HTTP is exceptionally good at ensuring client-initiated actions are safely authorized, processed, and written to the database as a single closed transaction. Once that message is saved, the server checks to see if the receiver has an active WebSocket connection. If they do, the server uses that lightweight broadcast engine to push the new message directly to their screen. This creates a distinct asymmetrical data flow. The sender talks to the server via HTTP, while the receiver listens via WebSocket. Assigning tasks to what each protocol does best allows these messaging systems to handle millions of interactions a second without crashing. There is one final constraint on mobile devices. When you lock your phone or switch to another app, the operating system completely severs all active WebSocket connections to save battery life. The server recognizes that the pipe is dead. Instead of trying to reach the phone directly, it diverts incoming messages to the operating system's push notification gateway, like Apple's AKNS or Google's Firebase. The operating system receives the notification and grants the messaging app a tiny 3-second background window. The app uses standard HTTP to silently fetch and save the message content without ever waking up the screen or forming a socket. A true WebSocket connection only reignites the exact millisecond your finger taps the notification to open the app. Creating the magic of real-time communication requires a precise orchestration of WebSockets, standard HTTP requests, and background system services, with each handling a specific piece of the data journey.